we'll continue with the chapter that is biomolecules. So in our last video we have seen about proteins. What are proteins made up of? They are made up of amino acids. We have also seen the classification of amino acid, and the classification is based on their acidic, basic and neutral characteristics, whether they are acidic, basic or neutral. Now we have also seen some of the essential and non-essential amino acids, right? Then we have seen the structure of amino acids. They are fibrous and globular. Now, globular structure is again divided to primary, secondary, tertiary and quaternary structures. We have also seen the denaturation of protein. Now, in today's video we will see about the enzymes, mechanism of enzyme action, vitamins, classification of vitamins. So let's start with the video. Now, enzymes. Now, life is possible due to the coordination of various chemical reactions in living organisms. As we know, our body, there are various chemical reactions that takes place, like start from our digestion of food to absorption of appropriate molecules from the digested food and ultimately producing energy for body, right? All these mechanisms, they require energy, and this energy is produced by various chemical reactions that take place in our body. Now this process involves sequence reactions, and all these reactions occur in the body under mild conditions. So there are various kinds of reactions that takes place in our body, and they takes place in a sequence of order, and this sequence of order of reaction, it occurs in a mild condition. Now in a chemical reaction we use catalyst to fasten or to carry the reaction, right? Similarly, in a biological body, the catalyst which carries the reaction faster, or which makes the reaction faster or which supports the reaction, is known as a biocatalyst, and it is called as enzymes. Okay, almost all the enzymes, they are made up of globular proteins. Okay, they are made up of globular proteins. Now enzymes are very specific for particular reaction and for a particular substrate. Now, similarly, when we use a catalyst, it is particular for all the reactions, right? We don't mix up the catalyst. Similarly, enzymes are specific for specific reactions or specific reactant or a substrate. Okay, now they are generally named after the compound or the class of compound upon which they work. So the names of these enzymes, okay, they are given according to the compound on which they work. Now compound on which they work, it means the reactant on which it attacks. Okay, now an example is given here is the catalysis of, to catalyze the hydrolysis of maltose into glucose. So conversion of maltose to glucose by hydrolysis. In this, a product or reactant is maltose, which is converted into glucose, and this reaction is catalyzed by an enzyme known as maltase. Okay, now this enzyme is named after the substrate on which it is operating, that is the maltose. Now apart from the substrate, these enzymes are also named after the reaction in which they are involved. Okay, now for example, an enzyme which catalyzes the oxidation of one substrate and simultaneously reduction of another substrate takes place. Okay, when a catalyst is used which is oxidizing one molecule and simultaneously reducing other molecule, now such enzymes are named as oxidoreductase enzymes. Now the ending of the name of an enzyme, it always ends with ASE. So the enzymes, if you want to identify, their names will always end with ASE. These three alphabets are always present at the end of the name. For example, oxidoreductase, maltase. Okay, there is a ASE at the end of the name. Now mechanism of enzyme action. Now, enzymes are needed only in small quantities for the progress of reaction. So it is not like you have to use too much of enzyme for a reaction. Enzymes are only needed in a small quantity, okay, and it is to progress the reaction. Okay, similar to the action of a chemical catalyst. How we use a chemical catalyst to initiate the reaction or to fasten the reaction. Similar thing is for the enzymes here. The enzymes are said to reduce the magnitude of activation energy. Now, for example, activation energy for acid hydrolysis of sucrose is 6.22 kilojoules per mole, while the activation energy is only 2.15 kilojoules per mole when hydrolyzed by the enzyme sucrase. Now, mechanism for the enzyme action has been discussed. Okay, mechanism I think we have discussed is in biology also you have discussed it, and earlier classes also it is discussed. Now, when we use an enzyme, the activation energy decreases. Activation energy means the starting of the reaction, the energy required to start the reaction. That activation energy is reduced when you use an enzyme. Here they have given an example of hydrolysis of sucrose. Without enzyme it takes 6.22 kilojoules per mole, but when you use an enzyme sucrase, the energy, activation energy is reduced to 2.15. Okay. Next is the vitamins. Okay, now it has been observed that certain organic compounds are required in small amounts in our diet, but their deficiency causes specific diseases. Now in our body there are various materials which are required to operate some of our organs, right? Now here there are some organic compounds which are required in very small amounts, but deficiency of them, deficiency means low amount of those organic compounds in our body causes specific diseases. Okay, now these compounds are called vitamins or vitamins. Okay, now most of the vitamins cannot be synthesized in our body, but plants can synthesize almost all of them, so they are considered as essential food factors. Now vitamins, most of them cannot be synthesized by our body. Okay, we usually take it through our diet because plants can synthesize almost all of the vitamins present. Okay, so it is essential as the food factor. Okay, now however the bacteria of the gut can produce some vitamins required by us. Now you know there are gut bacteria in us, right? Those gut bacteria, they produce some vitamins, but not all that required for us. Okay, some which are important for us. Now all the vitamins are generally available in our diet, so basically everything comes from our diet. Now different vitamins belong to various chemical classes, and it is difficult to define them on the basis of structure. There are different vitamins, okay, belongs to various chemical classes. They doesn't belong under one category, they belong under various categories, and it is difficult to define them on the basis of their structure. So they are generally regarded as now since we can't define them on the basis of their structure, we generally define a vitamin as an organic compound required in a diet in small amounts to perform specific biological function for normal maintenance of optimum growth and health of the organism. So they are organic compounds, okay, which are required in our diet in small amounts. We have to mention them in small amounts. Okay, so they are organic compounds required in our diet in small amounts to perform specific biological functions for normal maintenance of optimum growth and health of the organism. Now vitamins are designated by alphabets. Okay, they are designated by alphabets like A, B, C, D. Some of them further named as subgroups. Okay, the vitamins, they are categorized as alphabetically A, B, C, D, but some of them have subcategories. Example B1, B2, B6, B12, okay, etc. Now excessive vitamins is also harmful, and vitamin pills should be taken should not be taken without the advice of doctor. So vitamins are important for our body, but excess of them is also harmful. So whenever you are consuming a vitamin tablet pills, it should be taken with doctor's advice only. Without doctor's advice, it is not applicable to consume vitamin pills. Okay, it's not advisable to consume a vitamin pill without a doctor's proper advice. Now, the term vitamin was coined from the word vital and amine. Okay, since the earlier identified compounds had amino groups. Now, why they are named as vitamins is from vital amine. Okay, important amine. Now, this amine came from because some of those identified vitamins had an amino group in them. Okay, later work showed that most of them did not contain an amino group, so the letter E was dropped and the term vitamin or vitamin is used this day. So later this E was dropped because most of them doesn't contain an amino group. Okay. Now, classification of vitamins. Now, vitamins are classified into two groups depending upon their solubility in water or fat. Okay. Now, vitamins on their solubility, on the basis of their solubility, they are classified into two groups. One which is soluble in water, the other which is soluble in fat. So we have a fat soluble vitamin, we have a water soluble vitamin. Now let's see fat soluble vitamins. Now, vitamins which are soluble in fat and oils but insoluble in water are kept in this group. As the name suggests, it is a fat soluble vitamin. So the ones which are soluble in fat and oils but insoluble in water are kept in this group. Now, the examples are vitamin A, D, E and K. Now, they are stored in liver and adipose tissues. Okay. Now, since they are fat soluble, they are stored in our liver and adipose tissue. Adipose is a fat storing tissue, okay, where fats are stored. Since they are fat soluble, they are in adipose tissues. Water soluble vitamins are B group vitamins and vitamin C. All the vitamins which fall under B group, that is B1, B2, B6, B12, B5, B7, all those vitamins which fall under B group, and vitamin C are soluble in water, so they are grouped together. Now, water soluble vitamins must be supplied regularly in diet because they are readily excreted in urine and cannot be stored, except vitamin B12 in our body. Now, since water soluble vitamins, when you consume, since they are water soluble, they directly solubilize and pass out through our urine. So we should always maintain vitamin groups like B and C, vitamin B and vitamin C in our diet. We have to always include these vitamins in our diet as they are readily excreted out of our body through urine and cannot be stored. But vitamin A, D, E, K, these are fat solubilized ones, no, so they can be stored in our liver and adipose tissue, but the water soluble ones can be easily dissolved in our body and can be thrown out through our urine. So those vitamins which are water soluble have to be included in our diet on a regular basis. Okay. Now, these are the names of vitamins, sources from where we can get them, and the deficiencies which they cause. Okay. Now, for example, vitamin A. Okay, vitamin A, the main sources are fish liver oil, carrots. Carrots is the main source of vitamin A. Butter, milk. Now, what are the deficiencies that caused by deficiency of vitamin A? If we have less amount of vitamin A in our body, main disease is the night blindness. You can get a night blindness or xerophthalmia, which is a hardening of your cornea in the eye. Okay. Now, next is the vitamin B1 or thiamine. You get B1 vitamin from yeast, milk, green vegetables, cereals. Okay. Now, what is the disease which cause when there is a deficiency? That is the beriberi disease. Okay, loss of appetite, retarded growth. Okay, beriberi, you continuously lose your appetite. Okay. Now, next is the riboflavin or vitamin B2, which we can get from liver, kidney, egg whites. And the disease that is caused is chiliosis, which is fissuring at the corner of mouth and lips. Here you can get some burn like things. Okay, digestive disorders, burning sensation on the skin. Okay, now next is the pyridoxine or the vitamin B6. Now the main sources are egg yolk, cereals. Okay, the deficiency is conversions, which are very rare. Now next is vitamin B12. B12 we can get from meat, curd, egg, fish, all the fishy materials. Now here vitamin B12 causes pernicious anemia, which means RBC deficient in hemoglobin. Okay, in hemoglobin you can feel deficiency of RBC, that is pernicious anemia. Now pernicious anemia is basically caused because of vitamin B12, and why it is caused because of vitamin B12 is vitamin B12 is involved in the production of RBCs in our body. Okay, so if deficiency of vitamin B12 is there, so you get a pernicious anemia. Next is vitamin C or your ascorbic acid. Main source of vitamin C everyone knows, that are citrus fruits like your lemon, orange, okay, amla, green leafy vegetables. And the disease is your scurvy, that is your bleeding in the gums. Now vitamin D, from where you can get? As usual, you can get it from the sunlight, exposure to the sunlight, or fish and egg yolks. Now basic disease is rickets, bone deformities in children, and osteomalacia, soft bones and joint pain in adults. Okay, in children they get rickets, and in old or adults they get osteomalacia, which means soft bones and joint pains in adults. Now next is the vitamin E. Basic sources are vegetable oil like wheat, germ oil, sunflower oil, which we use nowadays. Okay, now deficiency causes increased fragility of RBCs and muscular weakness. Okay, there is muscular weakness. Next is vitamin K. You get it from green leafy vegetables. Now increased vitamin K or deficiency in vitamin K increase blood clotting time. Okay, because vitamin K is involved in the clotting of bloods. So if there is deficiency of vitamin K, the time taken to clot increases. Okay, so there will be continuous flow of blood. Now this is for today's video. We have seen about the enzymes, mechanism of enzyme action, vitamins, classification of vitamins, and some of the vitamins, their sources, and what are the diseases that are caused because of their deficiency. So thank you for watching my video. Please do like, share and subscribe to our channel.